Hi there, Rachel Chase here, and in this video we will take a look at the addition rule for probability. For this section, we will need to understand what it means for events to be mutually exclusive. Events are mutually exclusive if they can never occur at the same time. So an example of mutually exclusive, there's really many options you can consider. Now if you think for a moment about picking a card out of a deck, things that cannot happen at the same time would be something like selecting a red or a black card at the same time, because the card will either be one color or the other. You could not select a queen and a king at the same time, again, if you're only picking a singular card. So those are examples of what it means to be mutually exclusive. Examples of things that are not mutually exclusive would be something like selecting a black card or a king at the same time, because there are two kings that are also black cards at the same time. There's really, again, many different options of what can occur there. Now, the actual addition rule comes down to this. Most books split this up into two things, but I always tell people, use your common sense here. The probability of an event A or another event B occurring is given by adding their separate probabilities together and then subtracting out when they happen at the same time. So why do I say subtracting out when they occur at the same time? Well, if your events are mutually exclusive, then you'd end up subtracting 0. However, if they do have overlap, this avoids you double counting it. So when your events are mutually exclusive, this part is equal to 0. So it would just be the first portion of this, probability of A plus probability of B. How does the addition rule work when you're dealing with complements? Well, earlier we defined the complement as 1 minus the probability of the original event. So the addition rule works as such. The probability of an event plus its complement is going to be equal to 1. So again, if you wanted to solve for this, you would subtract that over, and you can see how the rule from earlier came to be. Let's take a look at some examples. Consider the sample space of the gender of two children being born. To do this, you have a few options for constructing it. The first would be to use a tree diagram, or the second would be just to make the list in your head. So what are the possible outcomes when a child is born? You could have two girls. You could have the first child be a girl, the second be a boy. It could be the other way around, male or female. Or last but not least, you could also have two boy children. So if this is our comprehensive list, this is what we call our sample space that we learned about earlier. Find the probability that there is at most one girl. So think about that. What does at most one mean? At most means no more than. So any number smaller than or equal to that value. So which of these examples have at most one girl? Well, this one has only one, this one has only one, and this one has none. So all three of those are considered at most one girl. So we could say 3 out of 4, or 0.75. Why does the addition rule work here? Well, let's spread that out. The probability of at most one is equal to the probability of 0 girls plus the probability of 1 girl. So whether we recognized it or not, that's actually what we did when we were identifying these up here. How many times are there 0 girls in a family? Only 1/4 of the time. How many times are there 1 girl? So exactly 1 girl. That was 2/4, which is where our 3/4 comes from. What about finding the probability that there is at least 1 boy? So same thing as before. At least, however, means from that value or higher. So the probability of at least 1 boy is equal to exactly 1 boy plus the probability of exactly 2 boys. How many times do we have exactly 1 boy? That would be 2 out of 4. And how many times do we have exactly 2 boys? That would be 1 out of 4. So you'll notice here it's not a coincidence that we get the same answer we did in the first one, because these two things are actually interchangeable, at most one girl and at least one boy. That's not something you have to recognize, but you should recognize that these aren't necessarily coincidence. As you practice these, you'll begin to get more comfortable with them. Now, let's take a look at this type of table, which is called a joint probability table. Anytime you have a joint probability table, the first thing you should always do is take a moment and tally up everything you have in here. So you're going to count up your rows and also your columns. So let's take a moment and do this. Now that we have our rows and columns totaled up, let's take a look at some probability questions. What is the probability of selecting a red or white vehicle? So can a vehicle be red and white at the same time? According to this chart, they are completely separate. There's no overlap with them. So we would call those mutually exclusive. So we can write that like this. Again, since there's no overlap, you could say probability of red and white. So in this case, this last piece would just equal to 0, so there's nothing to subtract. What's the probability of selecting a red vehicle? There are 15 red vehicles out of 52. And how many white vehicles do we have? 22 over 52. So we add those together, and we get 37 out of 52. So go ahead and calculate that as a decimal just to give us an approximate. Gives us about 71.2%. So that's 0.712. What is the probability of selecting a black vehicle or an SUV? If we look at our chart here, we see that there are 15 total black vehicles and 15 SUVs. However, they overlap, and it tells us that 8 of those SUVs are also black vehicles. So in this case, we can say that those events, because of that overlap, are not mutually exclusive. So how could we set this up? Just like we did before, write things out. The probability of selecting a black vehicle or an SUV is equal to the probability of selecting a black vehicle plus the probability of selecting an SUV minus their overlap, so probability of selecting a black SUV. We said that 8 of those are counted twice, so we have to subtract out 8 out of 52. And then we have 15 black vehicles and also 15 SUVs. So fill in what we know. So this gives us here, just go left to right, 30 minus 8 is 22 over 52, which we can reduce if we want to or turn into a decimal. So this would give us 11 over 26, which is about 42.3%. In our next video, we will explore using the multiplication rule for probability. Thanks for watching.